Today's discussion is about Juniper Apstra. So what is it? I think it's maybe the first question. So Apstra is a solution used to manage the full life cycle of network infrastructure in data center environment, right? We are talking about the data center environment. So again, to manage a solution to manage the full life cycle of your network infrastructure. And what really differentiates Apstra from other solutions is that Apstra is a multi-vendor solution. So that means Apstra can manage, three main players on the market, which are Juniper, Arista, and Cisco, as well as some other players like such as Dell Sonic. So what that means that everything we are discussing today is not Juniper specific, right? So keep this in mind. You can manage, again, you can use Apstra to manage a Cisco network or Arista network as well. But so why are we talking about Apstra? And actually, I think the question should be why such a solution becomes more and more relevant and needed in today's environment. So the first answer to this question, I think it's complexity, right? So and we need to look at how data center network have evolved, have become more and more complex and complicated over time. So we started, back then, we started with pretty simple flat network where spanning tree was the only the only feature we used. Then we moved to a second generation of data center based on a three-tier design, core, aggregation, access. And with this new design, new feature got introduced, such as IP routing, VPC, MLAG, MCLAG, stuff like that. But these features were located at the aggregation layer where we had only two switches. Right, so yes, it was a little bit more complicated, but still manageable because we were talking about just two switches. But lastly, we moved to a third generation of data center that we called Fabric, and this Fabric drastically increased the complexity and the scope of this complexity within the data center. And this is what we're going to see in the next slide. So here is an overview of what a fabric design is for some of you, who has never seen something like that, right? So it's a two-tier design. We have a spine and a leaf tier. The leaf tier is where we connect the endpoint, and such a design offers a lot of benefits, right? Scalability. If you need more ports, you add more. You add leaf switches. If you need more throughput between the leaf switches, you add more spine switches. It's a multi-tenancy environment. So you have one physical network that can support multiple environments, production, staging, whatever you want. Everything is segregated. And really the benefit also of this new design is mobility between locations, right? So you can stretch subnets between multiple locations, which allow the server team to seamlessly move one VM from one location to another one without changing the IP space. Oh, sorry, what happened here? Go back. And we needed something like that, to support what everybody called digital transformation. But like before, to support all those benefits, so new features got introduced, and especially VXLAN, BGP, VPN. But one of the main differences between this third generation of data center and the previous one is that the complexity exists on all the switches that are part of this network fabric, right? So we are not talking about two switches. It's really all the switches needs to run these new features to make it work, right? So if you have a data center with 50 switches, you need to manage this complexity and VXLAN and VPN on 50 switches. So, and I think this is a key, this is the main answer to the question, right? Complexity. So how do you manage this complexity? Yes, an answer can be automation, right? Let's use Ansible playbooks. So it's going to help me. Yes, definitely you can use Ansible playbooks, but I do see some limitation. The first thing is not everybody has skills, right, to implement automation. Some customers do not have skills in-house. The second thing is, if your environment is a multi-vendor environment, it requires a lot of maintenance because you have to maintain playbooks and script. You need multiple copies of the script because you have multiple vendors. And every time you upgrade your network, you might need to upgrade or update the playbooks, the scripts to support new features, right? So it's a lot of work. And again, not all customers have the skills in-house. And the last things is Ansible playbooks or scripts are pretty good to do, building the network, like what we call day zero automation, but that's it, right? It's not, these things do not cover the whole life cycle of a network, right? What about the monitoring, the troubleshooting, right? So, and Ansible playbook, again, they are not good at this. It's really, we're talking about day zero operation. So when we look at this next slide, which is describing the whole life cycle, and this is what you see on the left-hand side of this slide. The life cycle is made up of 3 phases. The building phase, this is where you design and you configure your network. The monitoring phase, this is a green block here, and the troubleshooting phase, right? And I hope you are going to agree with me on the following statement is operation have always been a struggle, right? Because of a lack of links of feeding mechanism between these various blocks, right? Like when you do something when you build something, you build your configuration in this building phase, and that's it. This building phase doesn't feed the monitoring phase. So what that means to configure the monitoring phase or the monitoring tools, you need to go and redo the work, right? Someone has to do it, right? And most of the time, because there is no feeding mechanism, right? The result is that the monitoring is not 100% accurate. Some key components are missing, or maybe you are configuring too much things which generate too much noise, right? So it's not efficient. And same thing with the troubleshooting block, right? Because the monitoring is not 100% accurate, it becomes challenging for the network operators to identify an issue and fix it. So what happens, what we see, it's usually when the problems comes up, the problems get quickly escalated to the engineers who did the implementation, right? Because you have no other options. If you want to fix it, you need to go back to the engineers who did it. So why, I mean, what if we could close this loop and connect these phases together, and one phase feed the next one and close the loop this way and make everything simple, right? So this is what you see here, like this green line. Let's connect everything and make it simple. And this is where intent-based networking solution, and especially Juniper Apstra, come into the picture. So it's one single solution that takes away the complexity of a network and takes care of a full life cycle, right? So how it works, we start with the design. So you define your design, you define the specification of your network. And to do that, just user express an intent. It's pretty basic. I want to build a fabric with 2 spine switches and 10 leaf switches, right? I want to configure a network, and this is the subnet. I want to connect to server, that's it, right? You just answer simple questions. And what the solution does, it's the solution ingests the intent and translate the intent into a configuration. And when the solution create the configuration, the system use vendor and industry best practices, right? So you follow you follow best practices. It's not something you do on your own, it's everybody with such a solution, you follow what everybody's doing. And after that, you have a config. So the system has the configuration and deploy the changes to the switches. And when the configuration has been deployed, the solution start monitoring the whole infrastructure right away. You don't have to go and configure your monitoring tool. The system does it for you and provide a simplified view of the state of the network and validate that the way the network is running matches the intent that the user expressed when we did the design, right? And as soon as there is a deviation, like a BGP session between the leaf and the spine goes down, or configuration on a switch has changed, the solution trigger or raised an anomaly in the web UI, And at this point, the user can log in the solution, can log in Apstra, and look at the issue. Or you can also imagine that the solution can correct the issue on its own. Right? This is what we call self-operation. Another thing that the solution can do is raising anomaly before something happens. Think about the transceivers, right? So what the solution can do, it's monitoring the state of the transceivers and let you know that the transceiver is about to die. So doing this, you can avoid an outage, and you can schedule a maintenance window, just replace the transceiver before getting an outage. So this is quick. We don't have too much time, but this is what Apstra does, and Apstra does it in a multi-vendor environment. So again, not only for Juniper switches, you can use Arista and Cisco as well. So let's jump into the web UI and take a quick tour of the product. So I'm going to stop here, and you should see. Okay, can you see the screen, Chris? Yeah, you're good.
Yes, you're good.
So this is the web UI, and when you log into Apstra, you land into this on this main view, right? And what we see here, it's that Apstra is managing 4 environments, right? This is what you see here: 4 lines. A line is an environment. It can be a fabric, it can be a collapsed fabric, it can be whatever it is, right? But under Apstra right now, we have 4 environments that are managed or operate. So again, to build these blueprints of this environment, we've created some templates ahead of time here. And what these templates does, it's define the specification of the network, right? And again, as I said, it's pretty simple. It's not really technical discussion here. It's a template defined how many switches or spine switches do I need, how many leaf switches I want. So 2 spine, 6 leaf switches, how you want to pair the switches together, the speed, how many ports you want on the leaf switches, stuff like that. You build the template, and when the template is built, you can instantiate the template, and this template becomes a blueprint, right? And the blueprint is tied to a production environment. And just go back to the main page. So again, you log here into Apstra, you land on this main view. What you quickly see here is you can get the state of your environment, right? You're just looking at the sticker on the right-hand side. So for the demo core environment here, you can see all the stickers are green, so everything is fine. For the demo fabric environment, we do have some red sticker. So again, it looks like there are some anomalies, right? So you can click on this environment, the demo fabric, and now you're going to get more details. And quickly you can identify that, yes, it looks like I have some cabling issue, I have some BGP issue, I have some config deviation issue, I have some other probes that the system is raising here, and I have some route verification. So meaning I'm missing some routes in the routing table, and maybe it's because of the BGP issue, right? So again, it's easy and quick to identify what's going on here. And then if you want to get more details, you can click on one of these stickers, and we can click on the BGP sticker. And here what the system is telling you, it's that for this particular BGP session on leaf 4, and you have some details about the BGP session, we expect an up state, but actually the state is down, right? So quickly you can identify what's wrong. If we go back, sorry, to go back here. If we go back here and we look at the config deviation anomaly, you click on it, looks like it's something tied to leaf 6. So you click on this guy, you go to the config tab, and now Apstra is showing you the intended configuration on the left-hand side and the actual running configuration. So you go to next diff, and quickly you can see that, oh yes, this section highlighted in green is actually a section that exists on the switch, but is not intended. And you can fix it quickly. You can go back up and say, apply the full configuration. And what Apstra is doing is applying the intended configuration on the device and fixing the issue. and everything is okay now. So, and again, you have many things like this, so you can quickly identify issues. In addition to these things, Apstra instantiates some probes. And so I'm going to go here. And these probes are going to give you more insight about the fabric, like CPU utilization, memory utilization, stuff like that. Or like, and some of the probes are coming, you know, when you build the blueprint, some of the probes are instantiated automatically. So you don't have to do anything. But if you want to do more, and this is like instantiated the first probe here, which allows me to monitor some critical links between the fabric and some end devices and get some trends. So this way I know that the bandwidth on these links are slowly increasing over time. And when this bandwidth reach a threshold, I'm getting an alert, and I know that I may have to look into this. I may have to improve to increase the bandwidth of these links. So you can avoid some outages. And all these probes, I mean, we can dive it here. It's pretty technical. So what you can do is you can instantiate some widgets, and you can create some dashboard. And this is exactly what I'm going to show you here. So we have a widget tied to the probe that I just showed you that is a summary of what's going on. And for instance, I have 8 devices with a high CPU utilization, and you know, I get an anomaly in the here on the dashboard, right, on the web UI. So this is for the monitoring part. Again, you build the fabric, and automatically you have some monitoring in place. And you don't have to build anything. It's part of the product. Now, to manage this configuration, you go to the stage tab, and I'm not going to show you how to create a network, how to connect a server, but we don't have time for this. What I want to show you here, it's when you configure this fabric, you get a visual view of it, right? So here you can see, just looking at it, I have a good understanding of how my fabric is set up. I have 2 spines, 6 switches. I have a bunch of servers connected into the switches. If you want to know more details about the connection of a specific box, you can click on it, like server 2, and you're going to quickly see that this server 2 is connected to NIF 3 and 4 into interface 3, and it's a port channel. And then you can move to virtual network endpoint, and you know exactly which VLANs are pushed down to the servers, right? So again, you do the configuration here, but what I want to show you, it's this tab, this stage tab, is also becomes your documentation, right? So as a network operator, you just come here and you can quickly locate the server, how the server connect to your network, and also quickly identify that an issue exists and where this issue exists on the fabric. And lastly, one of the nice feature as well of the product is when you stage your device, you stage your configuration, the configuration is not pushed right away to the devices. You have to commit the change. But before you commit the change, the Apstra grab a snapshot of the fabric, the network fabric, and if something happened, you can easily roll back the change fabric-wide, right? So, and this is the time Voyager feature that you see on the right-hand side. So every time you make a change, there is you can add the description. You can the system grab a snapshot, and if something goes sideways, again, you can roll back to one of these snapshots as well. So again, you know, we are making changes at night. The next day, something is really doesn't work. If you come here, you revert the change, and everything is working again, right? So, and that's it, right? We don't have enough time to go deeper, but I hope you got a good sense of what Apstra can do, and the benefit of what this solution can offer, and why you need to use such tool to manage and operate your data center networking. Thank you very much.